Hello grade 9 students. Welcome to another virtual class. I am Miss Madhu Vadge. Today we will start with a new chapter, chapter number 8, Quadrilaterals. Even though you have studied about quadrilaterals in lower classes, in today's video lesson we will revisit the basic concepts related to quadrilaterals. We will also show that the sum of angles of a quadrilateral is equal to 360 degrees, and we will learn about various types of quadrilaterals and write down their properties. Let's consider these 4 points. If we have 4 points which are collinear, then on joining them we obtain a line. But let's say out of these 4 points, 3 points are collinear. Then on joining these points, we will get a triangle. If no 3 points are collinear, as shown over here, then on joining these points, we will get a 4-sided closed figure. So a figure formed by joining these points in an order that are lying on a plane is called as quadrilateral. These lines that enclose this two-dimensional figure are called as sides. So a quadrilateral has 4 sides. Any two adjacent sides of the quadrilateral meet at a point. Let's label these points as A, B, C, D. These points are called as vertices. So a quadrilateral has 4 vertices that are A, B, C and D. And now we can write the sides AB, BC, CD and DA. The two adjacent sides of a quadrilateral form an angle. We can call this angle as D or angle CDA. Similarly, this angle will be angle DAB and this angle will be angle B or angle CBA. Similarly, this angle will be angle DCB or just angle C. We can name these angles with just the vertex, as there are no overlapping angles having common vertex. Observe that the vertex opposite to A is C and the vertex opposite to D is B. So if we join the opposite vertices, we get 2 lines and these lines are called as diagonals. So a quadrilateral has 2 diagonals, AC and BD. Now let's prove the angle sum property of a quadrilateral. So here is a quadrilateral ABCD. Let's draw the diagonal AC. This diagonal divides the quadrilateral into 2 triangles, triangle ADC and triangle ACB. And we know that the sum of angles of a triangle is 180 degrees. So using the angle sum property of triangle, we will prove the angle sum property of a quadrilateral. Let's mark angle DAC as 1 and angle CAB as 2 and angle DCA as 3 and angle ACB as 4. We are trying to show that the sum of interior angles of a quadrilateral is equal to 360 degrees. So we have to show that angle A plus angle B plus angle C plus angle D is equal to 360 degrees. In order to do that, we have drawn the diagonal AC. So let's use angle sum property in triangle ADC. Angle D plus angle 1 plus angle 3 will be equal to 180, as they are the interior angles of this triangle. Similarly, using the angle sum property in triangle ABC, we can write angle B plus angle 2 plus angle 4 is equal to 180 degrees. Now we will add these two equations. So we get angle D plus angle B plus angle 1 plus angle 2, I am writing these two in the bracket, plus angle 3 plus angle 4 in the bracket equal to 360 degrees. Now from the figure, angle 1 plus angle 2 is angle A, and angle 3 plus angle 4 is angle C. So this shows that the sum of interior angles of a quadrilateral is equal to 360 degrees. Next, we will study about various types of quadrilaterals. If you look around, you will find many objects that have the shape of a quadrilateral. Most of the objects have a rectangular shape or a square shape, like the floor, walls, ceilings, windows, your TV screens or your mobile screen. Even the top of your book is rectangular. So even though most of the objects around you have a rectangular shape, which is one type of a quadrilateral, we are going to study various other types of quadrilaterals as well, and we will specially focus on properties of parallelogram. So let's start with the simplest type of quadrilateral, which is called as a square. A square is a quadrilateral in which all sides are equal. So AB is equal to BC is equal to CD is equal to DA. In a square, each angle is 90 degree, which means all angles are equal. And if you measure the diagonals of the square, they are going to be equal. So AC is equal to BD. Also, the diagonals bisect each other at right angles. So if the diagonals intersect at point O, then DO is equal to OB and AO is equal to OC. And AC will be perpendicular to DB. The second type of quadrilateral is called as rectangle. In a rectangle, opposite sides are equal. So AD is equal to CB and DC is equal to AB. So the first property of this quadrilateral is that opposite sides are equal and each angle is 90 degrees. So all angles are equal. Let's draw the diagonals. If you measure these diagonals, they are also going to be equal. So we can say that AC is equal to BD. Can we say that these diagonals are cutting each other at 90 degrees? We can clearly see from this figure that angle DOC is an obtuse angle. This means that the diagonals do not cut each other at right angle. But they are definitely bisecting each other. So we can say that DO is equal to OB and AO is equal to OC. So here diagonals bisect each other. Remember, they are not perpendicular to each other. So DO is equal to OB and AO is equal to OC. The third type of quadrilateral is called as a parallelogram. Why it is called as a parallelogram? Because opposite sides in a parallelogram are parallel. So AB will be parallel to DC and AD will be parallel to CB. What about the length of the sides? If we measure the sides, we will find that the opposite sides are equal. So we can write this property as well. Opposite sides are equal in a parallelogram. So we can write AB equal to DC and AD equal to CB. Let's draw the diagonals. Can you say that the length of the diagonals will be equal? Visually, AC appears to be shorter than DB. And if you measure, you will find that AC is definitely shorter than DB. So in a parallelogram, diagonals are not equal. Are they cutting each other at right angle? Clearly, from the figure we can see that the diagonals are not perpendicular to each other. You can verify this by actual measurement. But are these diagonals bisecting each other? Yes, the diagonals bisect each other in a parallelogram. So we can say that DO is equal to OB and AO is equal to OC. Are there any more properties related to the parallelogram? Yes. The opposite angles of a parallelogram are equal. So angle A will be equal to angle C and angle D is equal to angle B. Fourth type of quadrilateral is called as rhombus. In a rhombus, all sides are equal. So AB equal to BC equal to CD equal to DA. And we know that in a square also all sides are equal. So is rhombus a square? No, because the angles of a rhombus are not 90 degrees. So clearly angle A will not be equal to D, D will not be equal to C, and so on. So any two adjacent angles are not equal. However, the opposite two angles are equal. So angle A equal to angle C and angle B equal to angle D. Can we say that the opposite sides in a rhombus are parallel? Yes. A rhombus is a special case of a parallelogram. A rhombus is a parallelogram in which the adjacent sides are equal. So we can say that the opposite sides are parallel in a rhombus. So we can write AB parallel to DC and AD parallel to BC. If you join the opposite vertices, you'll find that the diagonals bisect each other at right angle. So AC will be perpendicular to DB and DO is equal to OB and AO equal to OC. Can we say that the diagonals are equal? From the figure we can see that DB is longer than AC. You can measure and verify. So in a rhombus, diagonals are not equal. This type of quadrilateral in which we have one pair of opposite sides parallel is called as a trapezium. So in quadrilateral ABCD, we have AB parallel to DC. This quadrilateral is defined only with this property. There are no other properties related to the sides or angles or diagonals. However, if the non-parallel sides DA and CB are equal in length, then this trapezium is called as isosceles trapezium. So in an isosceles trapezium, one pair of opposite sides will be parallel and the other pair of opposite sides, which is not parallel, will be equal in length. And related to isosceles trapezium, we can show that angle P will be equal to angle Q and angle S will be equal to angle R. We are going to prove this later in the chapter, as it is a question given in the exercise. Sixth type of quadrilateral is called as a kite. As the name suggests, this quadrilateral looks like a kite. In a kite, we have two adjacent sides equal. So AB is drawn equal to AD and BC is drawn equal to DC. And if we join the opposite vertices to get the diagonals, these diagonals will be perpendicular to each other. So AC will be perpendicular to BD. Are these diagonals bisecting each other? No. However, diagonal AC bisects BD. This implies that BO is equal to OD, but AO is not equal to OC. So these are the properties related to a kite. Now we are in a position to draw a quadrilateral tree. We are going to draw a flow chart of the quadrilaterals for which we have written properties. So we studied about this shape, which is a trapezium which has one pair of opposite sides parallel. A special case of trapezium is an isosceles trapezium, in which one pair of opposite sides are parallel and the other pair of opposite sides, which is non-parallel, are equal. Then we studied about kite. In a kite, two adjacent sides are equal and the other pair of adjacent sides is also equal. The diagonals are perpendicular and only one diagonal is bisected. Then we studied about the third type of quadrilateral, which is a parallelogram. A parallelogram has opposite sides parallel and equal. The diagonals will be bisecting each other. Now a parallelogram that has all sides equal will be called as rhombus. So a rhombus will satisfy all properties of a parallelogram, that is, opposite sides will be parallel and equal and the diagonals will bisect each other at right angle. So we can say that a rhombus is a parallelogram. Then a special case of a parallelogram will be a rectangle. So if in a parallelogram all angles are equal, then we get a rectangle. So a rectangle will also satisfy all properties of a parallelogram. That means opposite sides will be parallel and equal. The diagonals will bisect each other. So we can say that all rectangles are parallelograms. Now a special case of rhombus can lead us to a square. If in a rhombus all angles are equal, then each angle will be 90 degrees and we get a square. So a square will have all properties of rhombus. That means all sides equal and opposite sides parallel. The diagonals will bisect each other at right angle, like it happens in a rhombus. Similarly, a special case of rectangle will lead us to square. And what is that special case? If the adjacent sides of a rectangle are equal, then we get a square. So we can say that all squares are rectangles, because a square will satisfy all properties of a rectangle. So these four quadrilaterals, parallelogram, rhombus, rectangle and square, are related to each other in this manner. A parallelogram that has all sides equal will be a rhombus. A rhombus that has all angles equal will be a square. A parallelogram that has all angles equal will be a rectangle. A rectangle that has adjacent sides equal will be a square. So looking at the tree, we can say that a square is a rectangle and also a rhombus. Can we say that a parallelogram is a trapezium? Yes, because a trapezium is a four-sided figure with one pair of opposite sides parallel, and a parallelogram satisfies this property. Can we say that kite is a parallelogram? No, kite will not be a parallelogram. Similarly, a trapezium also will not be a parallelogram, as a trapezium has only one pair of opposite sides parallel, whereas a parallelogram has both pairs of opposite sides parallel. Can we say that a rectangle or a rhombus is a square? No. A rhombus cannot be called as a square. Similarly, a rectangle cannot be called as a square, but a square can be called as a rhombus or a rectangle. With this, we come to the end of this video lesson. Your assignment for today is to show that the angle sum property of a quadrilateral is 360 degrees. Then write the properties of various types of quadrilaterals. You can write this in a tabular form so that you can compare the properties and it's easy to memorize. And then you can draw a quadrilateral tree. All this is to be done neatly in your notebook. See you in the next class. Until then, goodbye.